Hey, welcome everybody to the Daily Space Weather. We got some new sunspots rising and lots of other interesting stuff happening here. Here's the sun in two wavelengths, 94 and 335 angstroms from the SDO. Colorized magnetogram showing us a new sunspot group rising. It's now beta class. Likelihood of solar flares has gone way up as a result of that. The other two sunspots closer to the western limb are now continuing to degrade here. They're barely sunspots anymore, but this one down here is growing pretty promptly. And you'll be able to see that from the fields. So we've got some coronal mass ejections to show you as well here. And you can kind of see the coronal mass ejection on both of these images coming out of the southeastern limb there. Radio flux still pretty low here. I think it's at 79. There's the 1-year chart of the radio flux. To put it in context, that black line is the radio flux. Only 78 for the 10.7 centimeter radio flux. That is, the units there is solar flux units, which is 10,000 joules of radio flux density. So no forecasts here, no forecast for geomagnetic unrest or anything at the moment. The coronal mass ejection was not Earth-directed, according to available coronagraph imagery. There is an earthquake drought going on. If you look at this graph here, you can see the space between the red bars is quite large at the moment. Let's get back. There you go. That's the last 90 days of earthquake activity, so we are due, well overdue, for a 7 magnitude quake here. A little bit more earthquake activity than we reported yesterday in yesterday's video. So no major quakes here. There was a deep one at the Mariana Islands, near the deepest part of the ocean. By the way, one of the more interesting parts of the planet there near the Mariana Trench. Also a deep quake at Wallis and Futuna, near the Fiji-Samoa area. A deep quake at Fiji at over 560 kilometers estimated depth there. That's a 4.8 magnitude. If that happened at the surface, that would be like a 6 magnitude quake, folks. I think the largest was a 5.5 at Papua New Guinea. No, there might have been a larger one at Central America. Let's continue up the chart, up the report here from USGS. Oh, that's a 5.4. So yeah, Papua New Guinea was the largest quake at a 5.5. 5.4 was that El Salvador quake. That happened early this morning at 5:56 Universal Time, a few hours before we recorded this video. Panama seeing a couple of quakes here as well. The high 4 magnitude range. And another deep quake at Fiji. So a little bit of an uptick in activity since yesterday. Keep in mind, folks, some of those could be foreshocks. Next, we'll look at volcanoes. Doing a little geophysics to spice up the daily space weather. 8,000-foot ash plume still being produced by La Palma. Don't fly your hang glider over the caldera. It could be unfortunate. Subanosejima. Don't become part of a lava lake at Subanosejima. It's got a flight level 060 alert going on. Now Tal back on the list here, the Philippine phreomagmatically exploding sulfur dioxide producing volcano. Some seismic activity there as well. Semeru, flight level 140 at Semeru, that's in East Java, Indonesia, as it explodes. 14,000-foot ash plume. White Island now showing up here Some gas measurements. What do we got? Sulfur dioxide decreased. Carbon dioxide decreased. Also, hydrogen sulfide decreased. So a downtick of the gas emissions from the White Island volcano there north of New Zealand. Summit vent temperatures increased. Fuego exploding. That's in Guatemala, 15,000 foot ash plume from Fuego. Nevado del Ruiz, the Colombian volcano, also exploding. Flight level 200. Sangay, flight level 200. It's exploding as well. Don't attempt to fly your John Denver style ultralight aircraft over the Sangay caldera. Revenador exploding. Flight level 150. We like to put out public service messages because so many people are stupid. Remember, folks, half the population is by definition of below average intelligence. Sabancaya, intermittent emissions from Sabancaya. Please don't square dance about the caldera. Don't build a campsite at the foothills of the mountain. Also, Nevados de Chilean, exploding, flight level 180. It's an 18,000 foot ash plume. Welcome to the Neo Renaissance. Check out our homepage for all kinds of links. If you've never seen the Smash Team website, I don't know what you're waiting for. You're probably looking for alternatives to pathetic social media sites and so on. You can post whatever you want at smashamash.com/forum. Links to that at the homepage too. Also links to some of our YouTube videos, like smashamash.org presents the sun. But most importantly, the link to the merch shop. So don't pole vault the caldera. Please tell your friends and foes not to pole vault the caldera. Today's featured product is the Do Not Pole Vault the Caldera socks. So we invite each of you to, please, Mensa, make Earth not suck again. It's up to you. It's up to you, folks. Every one of you essential personnel out there. Each one of you is essential. Even if you've been convinced by nonsense that you're not essential because of your vocation or something like that, that's nonsense and fraud. You are indeed essential. So please don't pole vault the caldera. If you're going through hell, keep going. That's a Winston Churchill quote for you. Our public service messages do not pole vault the caldera, because apparently in 2021 people still have to be informed of this. We expect accountability to be a thing. So who knows? Maybe next year there'll be accountability for all kinds of failures. The products are magnetic, and so's this data. The products, they're psychologically magnetic. They're attractive. Anyway, there's the GOES magnetometer over the past 3 days. There is a North Pole current sheet headed this way. Let's see if it's here yet. I wouldn't expect it to be. But it is speeding this way. And I think stereo A is now in a North Pole-oriented current sheet. You can see shown there in green, so we can expect a current sheet switch over soon. Don't expect anything catastrophic to happen. There's nothing scary about it in any way. Here's a line-of-sight view of the same data, essentially, but this also shows you the solar magnetogram since you're viewing from a line-of-sight perspective. You can see that blue line dipping down there toward the activity that we kind of forecasted yesterday, actually. So, yeah, and I don't look at the stereo A data, if you're wondering. I only look at the coronagraph. I don't look at the solar imagery directly at stereo A. And it's not because of a challenge or anything like that. It's just because I've got a lot of things to do. So here's the coronal hole plot. And the coronal hole plot is showing you some trans-equatorial North Pole coronal holes rotating in here as well. You can see here on the last image. One of these shows it better. I saw a trans-equatorial. There you go. There's some trans-equatorial North Pole coronal hole material for you. And here's a 193 angstroms series of images. That's from the Solar Dynamics Observatory and helioviewer.org. So yeah, this is going to be Sunspot 2898, I believe. And it is indeed already beta class. We confirmed this while doing show prep, although it could have degraded. the likelihood of flares much higher as a result of this new sunspot group. So here's the X-ray flux profile over the past 3 days. That's the GOES 16 and GOES 17 measurements at 3 different wavelengths, frequencies, whatever you want to say. Proton flux. No spikes in the proton flux. Those coronal mass ejections, they were not Earth-directed. However, they were forecasted. Let's look at the real-time solar wind next. The real-time solar wind. And we did see it recently dip here into negative BZ territory there. So the total field stayed consistent, you can see, but the BZ got quite into the negative territory there for a brief signal, which brought up a little bit of magnetic perturbation on planet Earth. We'll get to that in a moment. Current solar wind density just around 10 protons per cubic centimeter. Solar wind speed 508 kilometers per second. KP index is at 2. That's a measurement of global geomagnetism. If you're a new viewer, congratulations on finding that the channel exists. Don't forget to tell your friends and foes about us and share on Facebook. Let's bring this back. This is 4 hours of data of magnetohydrodynamic pressure. The scale on this is in nanopascals. So no major changes here in the past 4 hours, as the solar wind has been pretty consistent over that period, the period displayed in this imagery. So that's the geomagnetic moment from space. Here's the geomagnetic moment on the ground. Changes in Earth's B field, known as geospace delta B, and this is in nanotesla, which is the actual magnetic flux density. And you can see some magnetic perturbations here over both Antarctica and northern Asia, also Canada, and around the south magnetic pole, which is down here south of Australia. If you're wondering where things are in the solar system, we've got a gibbous waning. Let's do a 7-day forecast. There's a 7-day forecast. It's for a crescent waning. And if you're scared of Uranus, get your head out of Uranus. Seriously, it's ridiculous. If you're scared of planets, folks, take physics. Please take physics. Next, a star chart. And we've got the moon pretty high in the sky here over Lehigh Valley, Pennsylvania. Which is our current location, which could be drastically changing suddenly with nearly no warning. Next, the coronal mass ejection that we forecasted. It's not Earth-directed, but we really don't know the way a coronal mass ejection is going to propagate until it leaves the corona, or is in the process of leaving at least. The next slide is for stereo A, which will be on the left, and Lagrange point 1, the location of the LASCO C3 on the right. It also shows you Mercury here. And you can see this coronal mass ejection from the southeastern limb. Nowhere near Earth directed there. And let's move on. To a brief cosmology segment. Today's random number is 684. And this quote, random end quote number, 684, coincides with something. And it is 4U 1735-44. Great. A low mass X-ray binary / neutron star, also known as V926 SCO. That's some constellation probably in the southern hemisphere that I'm not familiar with. I won't try to pronounce it and embarrass myself. These are the X-ray outputs from this. What is it? Low mass X-ray binary? Low mass X-ray binary / neutron star. And whether you believe in neutron stars or not, you ought to believe in X-rays because those are the X-ray transients. the transient X-ray emissions from this object. And you can see it's got quite a cyclicity here. It's a little bit wild, but it looks pretty consistent as well. The lower left is the 30-day chart. Let's go check it out on SmBad and on the CDS portal. By the way, the CDS portal's right there. If you go from the transients page, to SmBad, and then you go from SmBad to the CDS portal to get probably more information than you can handle on this object. There are its photometric points, and you can see it's got some spectra across most of the electromagnetic spectrum. Let's take a look at it in various frequencies. First, optical on the DSS colored. There it is. It's showing up blue. And here it is in ultraviolet on the Galix. You can see a pretty significant signal from that low mass X-ray binary there. And we've got a fairly lousy image here on the XMM Newton. It's only a partial survey there. As you can see, it's quite bright. In that X-ray survey. And here's a really good looking one. This is from the Exosat Low Energy Telescope. Check it out. That's a really good X-ray image of it. The low mass X-ray binary, known as 4U1735-44. That's the quote random and quote object 4U. Today on the cosmology segment, and check out the astronomy picture of the day. It's some spectacular imagery from NUSTAR. You might recognize this star, its characteristic flaring features. Can anybody name that star? Can you name that star? Today's cosmology segment, by the way, was integrated to the daily space weather video. And you can read about interesting things at the NUSTAR website as well, such as the latest update their hard X-ray observations of the pulsar wind nebula G11.2-0.3. It's pretty far away, and you can get some great images of it there on the NUSTAR website. It's nustar.caltech.edu. That's today's cosmology segment. Check the other cosmology segments on our playlists. And you can find all kinds of links below this video to our other content. We've got some minor charging hazards here moving into the Pacific Ocean, currently over Mexico. Minor surface charging hazards caused by things like excess electrons. Here's the 1-year chart of the relativistic electrons. That's from Solon.info. Here's the 3-day chart. And we're just at moderate levels here, nothing to write home about. We are expecting some high levels here that could cause some communication failures and satellites to bake out and so on. We'll be keeping an eye on it. And when I say ion, pardon the pun, here's a diagram of Earth Van Allen belts. And here's your total electron content forecast, showing you areas more likely to have GPS errors. Quite a bit of GPS errors over the North American continent. You can see some anomalous high-density electron regions through which your GPS satellite needs to communicate with your handset. Next, we're going to show you the ionosphere, the F layer. It's at about 300 kilometers of altitude. And this ionogram shows you vibrational frequency in megahertz, millions of vibrations per second. There's a lot of vibration going on above your head. If you're frightened of CERN and you understand what this imagery means, then you should take a physics class, because if you're frightened of CERN, you don't know physics. Next, the anomalygram. You can see massive low-frequency anomalies continuing here over large portions of the Western world, including South America, North America. Also, all around the equator there, around India and so on, low-frequency anomalies happening. Most of Asia seeing some low-frequency anomalies overhead. Anyway, there's the latest image. There's the latest anomalygram. Once again, ionogram. That's 10 o'clock universal time. There's the anomalygram. See significant low frequency anomalies here at the moment. And let's blast through bonus features. We've still got massive filaments here on the southern portion of the sun. We're not going to shut down our coronal mass ejection warning. We're expecting additional coronal mass ejections to be showing up by the time tomorrow's space weather video comes out. Udaipur, India, this is the ground-based solar observatory. If you're wondering, it's part of the National Sunspot Observatory. You got to view the sun from different sides of the world all the time in order to really know what's going on. And congratulations on realizing our channel exists to help you understand what's really going on. Check it out. It's a beta-class sunspot group. There are the fields. And the likelihood of solar flare, again, has gone up quite a bit with that new sunspot group rising. So here is the closest star. Shout out to all of our stargazers. And here's some more spectacular views of it. The northern hemisphere in 193 angstroms. The southern hemisphere in the same wavelength. Coronal holes. New sunspot rising in the southeast. 171 angstroms at the same zoom level and location. And the way we started the video out was 335 plus 94. Thanks for tuning in, viewers. May that solar wind be at your back.